constants. This E content explains the productivity, process, measurement of primary productivity. Concept of productivity. The three fundamental concepts of productivity are: one, standing crop; material removed; then production rate. Failure to distinguish these concepts has resulted in much confusion in attempts to measure and discuss the production of animals and plants in different areas. Standing crop. Measurement of the standing crop revealed the concentration of individuals in the various populations of the ecosystem. This information is essential for judging the degree of crowding in each species is exerting a harmful or a bacterial beneficial effect. The standing crop is the abundance of the organism existing in the area at the time of observation. It may be expressed as a number of individuals, as biomass, as energy content, or in some other suitable terms. It includes yield to man material removed. It includes the yield to man organism removed from the ecosystem by immigration, and material withdrawn as the organic deposit. The ecologist is concerned with the natality and the mortality in various components of the population and with rates of metabolism and growth. He inquires not only into the different types of machinery in the factory, but also into the speeds at which the wheels are turning. Production rate. The third concept of productivity is the production rate, or the rate at which growth processes are going forward within the area. Here it explains standing crop, material removed, rate of production. I already explained the standing crop and relation to population growth. The relation of the size of the standing crop to the rate of growth of the population depends on three types of situations, which is illustrated. In the first, rapid increase in the population size is increased, leading to the relation of the population growth. In the second situation, the growth of the population is much slower, but the same utilized size of the standing crop is attained. In the third situation, the same period of time is required to reach equilibrium as the second, but a lower equilibrium level is established. In the initial growth of the population, the length of life of the individuals influences the steepness of the population curve, because the longer each individual lives, the faster will be total increase. When equilibrium has been reached, however, individual length of the life has no effect on the size of the standing crop. Determination of equilibrium level. What then does determine the magnitude of the standing crop at the equilibrium? The total biomass of the organism inhabiting an area always tend to increase. This is due to the numerical increase of the population and the growth in size of the individuals, or both. Determination of the equilibrium in this, the ultimate limit to the growth of the population is determined by the supply of nutrient materials and energy. Increase of some animal is checked by the accumulation of metabolites, by disease, or by intensified predation. In special instance, lack of breeding sites may be the chief factor limiting population growth. Regional differences. The total quantity of life that can be supported in an area at the full carrying capacity may be made of a few individuals of the large number of species or many individuals of the few species. Generally speaking, tropical communities tend to exhibit the former condition and non-tropical communities the later, but these are many exceptions. Material removed. Some may believe that the yield to man in the only component of the material concerned farmers, fishermen, hunters, and foresters, but losses from the area in the form of emigration and the organic deposits must be must also be considered. Permanent immigration of animal or plant life similarly represent loss of material from the ecosystem. Organisms may leave the area by their own locomotion, or they may be carried away by wind or water currents. And the activity of the natural predators results in the one-way transfer of organic material from one ecosystem to another. As when a fish hawk removes fish from a pond, the loss of material from the ecosystem under consideration is also be included in this category. Another type of loss is represented by dead organic matter. So this figure explains systematic representation of the relation of man's cargoes from an area, such as a natural foster to the supply of the material and to the reduction of the product in various ways. Production rate. The knowledge of the standing crop from the area or the yield from the area does not give a complete picture of the productivity. In addition, the rate at which the different constructive and destructive processes are going forward within the area must be considered. Since the plant produces herbivores, carnivores, and other components of the ecosystem are all transforming energy and material simultaneously, the evaluation of production rate is extremely complex. This is explaining energy transformations during unit of time in an idealized ecosystem with no net increase or decrease. First topic. The largest rectangle at the bottom represents the total amount of incident light reaching the area during the period under consideration. Second trophic level. When we apply the same line of reasoning to analysis of the energy transformation at the herbivore level, the plant material assimilated in the equal to the gross herbivore production. The third trophic level, the primary carnivores often eat only part of the prey that kill, and of course, only a fraction of the material is digested and assimilated. Thank you. Turnover. In our discussion of production rate, nothing has been said thus far about the length of the period considered. The time required for each type of organism to complete its growth, to die and decompose, and to start the cycle over again is known as the period of turnover. Efficiencies. The ecosystem in which the magnitudes of the rate of production at the different trophic level can be measured. Calculation may be made of the quantitative relationship of the various steps in the production. In addition, ratios including several or all of the steps within the trophic level or embracing more than one trophic level may be calculated. For the plant, for the herbivore, for the carnivore. Productivity of the land and the water, the terrestrial environment clearly has certain advantages. More light is usually available and all the plants are ordinarily much more abundant. For this reason, food chains can be shorter with the correspondingly greater efficiency of production. Because the soil does not have the mobility of the water medium, nutrients are typically more concentrated and products of decomposition tend to be retained as a humus near the surface of the ground where they can be immediately used again. On the other hand, the lack of water and the extreme changes in temperature are prominent among the disadvantages of the land as the place to live. Marine environment. In the littoral zone of the ocean and lakes, light is sufficiently intense for the growth of the both planktonic and benthic plants. Since the water in this zone is continuously mixed, nutrients are rapidly redistributed and food particles are carried in abundance to sessile animals. The disadvantages of the littoral zone include excessive molar action, considerable temperature change, and other special danger